Welcome to Study Loop.
All right. So for this problem, we are looking at the proton-proton type cycle inside the sun, and so basically we're just looking at the reaction. Uh, so for part A, we want to find out the energy for the reaction versus the losing mass. So just look at the whole cycle. We know that the Q energy is 26.2 mega eV, and we lost the four protons. So that will be 4 times 1.67 times 10 to the negative 27 kilograms. So the value is 6.3 times 10 to the 14 joule per second. Oh, sorry, per kilogram. And for part B, we want to know uh, the 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 losing rate of the mass. So we have we already have the power. So basically, just the dm over dt equal to the power over e over m. Okay. So the power is given the problem, which is 3.9 times 10 to the 26 watts, and divide by the one we found previously, that is 6.3 times 10 to the 14th joule per kilogram. So the value is 6.2 times 10 to the 11th kilograms per second. And for part C, we use another way to calculate this mass losing rate, because we have E equal m times c squared. So power is dE over dt. So in this case, just simply dm over dt times c squared. So we find dm over dt equal p over c squared. Okay. So we already know the value of p. So we can find that the dm over dt is 3.9 times 10 to the 26 watts over 3 times 10 to the 8th squared. So the value is 4.3 times 10 to the 9th kilograms per second. And for part D, as we can see that the mass losing ratio in part B is actually greater than the one in part C. That's because in the whole reaction, uh, the most mass are still are transferred into the helium, and the helium still stays inside of the sun. So that actually account for this difference. And for the last part E, so we want to find out the time when the mass has lost the 0.1% of its mass. So the total time, I put it here, the total time t equal to 0.1% of the total mass over dm over dt. So we utilize the result from the part C over here. Okay. So you can actually find that the result is 1.5 times 10 to the 10th years.